What can we say about math? A lot of people simply hate math, and then there are those for whom it comes easily. And this makes it all the more frustrating for the first crowd. Learning math on your own is hard to do even for the mathematically inclined. Someone needs to show you how to do it, how to do a given process, once or twice or 10 times, and then you need to practice it once or twice or 10 times. This is the only real difference between people who are good at math and those who aren't. One group simply needs to practice more. It's not fair, but there it is. Now, there's not a lot I can do to help you with a given math thing, a math process. But what I can do is help you memorize the dull stuff and free up some brain cells for the process. Trust me on this. It's a lot more fun to be working on one thing at a time than it is trying to remember what 7 times 9 is at the same time you're trying to understand what it is the process is. So what can we do to make it easier to learn math here and now, perhaps with flashcards? Well, learning the multiplication tables is a good start. But what about addition, subtraction, division, and all that? Well, for addition, just count on your fingers. Everybody does. For subtraction, take your best shot and then check it by counting on your fingers. For division, you turn the problem inside out. Instead of asking yourself how many times 2 goes into 6, ask yourself what times 2 equals 6. But you have to know the multiplication tables to do this, and rote memorization is the best way to go. But let's see just how big a task this really is. Maybe we can come up with some shortcuts, some little memory aids. Consider the multiplication tables up through 10 times 10. Looks like this. That's 121 facts we need to memorize, right? No grasshopper. Let's remember that 0 times anything is 0, and 1 times anything is that thing. By the way, this makes 1 the identity factor for multiplication. The other thing we need to remember is that 2 times 3 is the same as 3 times 2. This is a fancy way of saying that multiplication is commutative. But don't try swapping the order of things for division. So what does this do for our multiplication tables now? Well, for one thing, it shrinks it considerably, down from 121 things to 45 things we need to memorize. But even this is too many. Can you count by 2s? Practice if you need to. Make sure you don't leave anything out. 14 always eluded me when I was a kid. You can now eliminate the 2s rows. Now how about counting by 5s? 5, 10, 15, 20, 25, etc. Practice if you need to. Multiplying by 5 means you cut the number in half and add a 0 if it's even, or you add a 5 if it's odd. Multiplying by 10 is even easier. You simply stick a 0 at the end. How does our table look now? Down to 21 things to remember. But wait, today only, and if you call right now, I'm offering you a special limited time offer. If you'll learn to count by 3s, and then remember that multiplying by 4 is the same thing as doubling a number twice, here's what I'm going to do for you. I'm going to teach you a trick to multiplying by 9. What you do is add a 0 to the number and subtract that number. Or you subtract 1 from the number and figure out what it would take to add up to 9, and this is your second digit. Consider 3 times 9. 3 minus 1 is 2, and 2 plus 7 equals 9, so 3 times 9 equals 27. Notice that all the digits of the products of 9 add up to 9. You might use this technique to check yourself as you're developing confidence in your rote memorization. But I must stress, in the long run, rote memorization is simply the best way to go. So here's what's left to memorize, a whopping 6 numbers. But these are the numbers that everyone gets wrong, including mathematicians. So my multiplication flashcards sort of hit on these 6 things and help you with the tricks and rules, the counting by 2s and 3s and so forth. Next, you ought to memorize the decimal equivalents of a bunch of fractions. Many things involving measurement also involve fractions, and being able to go back and forth between decimals and fractions quickly and easily is going to make your life better. Easiest way to do this is to think of a dollar. For example, quarters. Quarters are easy. 4 quarters to $1. And so a quarter is, well, a quarter of a dollar, or 25% of a dollar, or 0.25, or just 25 cents. Then we cut quarters in half. Now we don't have any coin for 12.5 cents, but the word bit is an old-fashioned and informal way of saying 12.5 cents. 2 bits, 4 bits, 6 bits, $1, and you've heard that, haven't you? If you plan to deal with the stock market, or make cabinetry, or just pick out the right non-metric wrench when you're fixing your lawnmower, you might find it worthwhile to learn both the 16ths and the 32nds as well. Dimes are easy. 2 dimes equals a fifth, or $0.2. 4 dimes is 0.4, or 2/5 of a dollar. And this brings us to thirds. Now in America, we don't have any coins for a third of a dollar. The English do, I think. Not that I've ever understood their pennies and farthings and quids and such, but no matter. Memorize 0.333 and 0.666, and while you're about it, do 1/6, which is 0.1666, or if you prefer 0.17, and 5/6, which is 0.8333. Remember that 2/6 is a third, 3/6 is a half, and 4/6 is 2/3. After this, there are some squared and cube numbers and square roots and cube roots. These are nothing more than fancy multiplication and division problems, and they are perhaps a process that should be shown to you, but nonetheless, I urge you to memorize these numbers. If you do, algebra will be easier. Anyway, here are the numbers you need to recognize. There's one thing that seems to confuse a lot of my students, and I think I ought to take a run at it about now while we're raising things to the power of this and that. By the way, these little numbers, the things that we raise the numbers to, they're called exponents. If you have a line that is 1 long, 1 inch or 1 mile, it makes no difference, and double it, you've got twice as much line as you had before. But if you double the sides of a square from 1 until 2, the area becomes 4 times as large, and if you double the side of a cube, you end up with 8 times the volume. This is why we say 2 squared when we mean 2 to the second power, and by the way, this is 4. And when we mean 2 to the third power, we say 2 cubed, and this is 8. Add a few digits of pi to your memory banks. 3.14 is good enough for most people. If you want to be an engineer and get all mathematical, add 1 to the last 2 digits and you get 3.1415, but the next digit is 9, so 3.1416 is a little more accurate. By the way, your calculator will shoot it out to 7 or 10 decimal places, and this is more than enough accuracy to calculate the orbit of a satellite 1,000,000 miles out there. If you have plans to study trigonometry somewhere along the line, memorizing the square root of 2 will be helpful. It's 1.4142, and like pi and a few other useful numbers, it's a number that has digits that go way the heck out there. There are lots more numbers worth memorizing, but they're pretty esoteric. If you go far enough in mathematics, you will come across them and then decide for yourself if it's worth the bother of memorizing them, or if it's just easier to look them up. But memorizing these numbers, including multiplication tables, will make your life easier. Maybe even make math a little more fun. Let me know if you have any questions or comments, and thanks for listening.